The process mean and standard deviations are controlled in such a that the process mean is centered and at an equal distance of 3 sigma for the both UCL and LSL. So in 3 sigma, the defectives of your product quality 2700 defects per million. Such a process CP1, but that means the process ratio when the 1 is described is a barely capable, slight capable. Okay. If the CPO process ratio is greater than 1, the process capability becomes a progressive more robust. Your quality is a more robust. You uh, produce a more quality product. That means your process means and target will synchronize more closer. And our recommended statistical value of CP ratio as follows, like that. For two set specification and one set specification, in case of the existing process in any manufacturing unit, the CP ratio is a 1.33. This is the standard value in the statistics. Already statistics tell us. And one set specification, the CP ratio is 1.25. So you can measure, and how you measure in the next slide I'll show the how you create the control chart, how you create the CP ratio, how you measure the CP ratio. The next slide I'll show. This is the concept first. You just recapitulate your concept. And for the new process in the pharmaceutical sector, the CP ratio is a 1.5 for the two side specification, and the CP ratio 1.45 for the one side specification. Right? Understood? Next slide, you just see. See, now already I told the defectives. Actually, our focus first CP ratio will be better. Our focus, the defectives per million in your process, in your system, in your quality will be lesser. So higher the CP ratio, the lesser will be the defectives per ppm. So in the NASA technology or in any aeroplane technology, the 6 sigma, 8 sigma, 10 sigma, they are working. That means zero defectives. One defect is in the plane crash, many passenger will die. So there, so our pharmaceutical quality will be like that, will be like reach to the 6 sigma methods, right? So this is the table. This is a very interesting table. So see these tables. When the PC ratio or CP ratio 0.25, for the one set specification 2,26,628 defectives will show in your process, and for two set specification 4,53,255 defectives per million in your process system. That means quality is a very deteriorated. Suppose in case of the zero point 0.9, when your 0.9 CP ratio, actually it's all to be designed. You have to design in your system, right? So if you reach your CP ratio at zero point 0.9 for one such specification, it will see gradually reduced the defectives per million 3,464 only defectives, and in case the two set specification 6,935 defectives. Next, CP ratio when is a 1 for one set specification only 1350, and for two set specification only 2,700 defectives per million. This is called the 3 sigma. Understood? So already in India, in any pharmaceutical sector, most of the pharmaceutical sector maintaining that status. At the PC ratio, when the PC ratio 1 for one specification, it will reach 1350 defectives, and for two site specification 2700 defectives. Now, if you design higher the CP ratio, like that 6 sigma methods. See, here the 6 sigma PC ratio when 1.6, one site specification only 1, and two site specification only 8. Only 3, 6 sigma methods. So see, so our focus will be from 3 sigma to 6 sigma. in the next future in the pharmaceutical industry. Right? This is our challenge. So all students understood the concept, the how we execute, how we apply the by applying the statistical method, how our quality in the pharmaceutical sector reached in such a fashion that the defectives gradually will decrease. That's our the challenge. That's our defect. That's our the motto. And when the CP ratio 2, then one such specification only defective 0.309, 0.09, two such specification. Already this status in different developed country like you say European country, Latin America, others country, developed country already trying to reach at this level, 2 sigma. That means they are the 10 or 12 sigma makers. So আমরা কত পিছিয়ে আছি এখনো ডেভেলপ কান্ট্রি থেকে। আন্ডারস্টুড? নেক্সট, different international guidelines, ICH, FDA guidelines, already for our third world country approaching, you maintain the at least CP ratio 1.33. CP ratio 1.33 means at least you maintain 48 or 14 defectives per million for one site specification, and only 96 or 27 defectives per million for two site specification. So all regulatory guidelines, international guidelines, of course, ICH, US FDA, WHO guidelines, they already implemented, and they asked our Indian pharmaceutical manufacturer to carry on this, maintain this CP ratio. Understood? Acha. One thing is that except the sterile products that are designed to meet the CP ratio 1.6 to 1.8, that means sterile products is a very vital. Sterile products are entering in vivo system of our human body, and so here defectives should be very, very, very negligible, tends to zero. See, so in case of the sterile products, your CP ratio should maintain in between 1.80 to 2. That means 0.03 to 0.039, or for two site specification 0.06 or 0.0018. You have to maintain, because this one is the ultimate latest concept. PC ratio you have to reach 2, then zero defect. Already Japan trying to maintain their pharmaceutical products or pharmaceutical quality at this CP ratio, and that's why Japan is the more developed other than the countries of the world. This is the statistical quality controls. What is the purpose? Already I told, fluctuating condition with time, variation in the incoming materials, variation in the machine conditions, variation in the all equivalent environmental conditions, variation in the operator performance. This is the main factors we have to control, right? That statistical quality control engage all the following three methodology. How we maintain the statistical quality control? Number one is the acceptance sampling. Number two is the statistical process control, SPC. I already told SQC. SQC is the mother, and SPC is tools under the SQC. Understood? Statistical process control. Now for the design of the experiments, do it. Right? So ICH guidelines already quality by design, quality by specification, and quality by leaks management through the different Q8, Q9, and Q10 specifications. Actually, this design of experiment totally included in the research and development (R&D) sectors. And SPC, this one, number two, uh, is included with the productions, manufacturing units, and acceptance sampling totally involved with the store distributions, quality control. So different, we just divided the different segments of the pharmaceutical process or product. So there are different tools: flowcharts, check sheet, histogram, parado chart, cause and effect diagram, scatter diagram, control chart. But 1 to 6, all are the old methods. They have been obsoleted. Now the seventh point is a control chart. This is a very vital point. In the current scenario, all pharmaceutical sector maintain the pharmaceutical quality through the control charts. By applying the 3 sigma or 4 sigma or 6 sigma method, this is a control chart. Actually, it is a tools, basically tools of the SPS, statistical process control. Is very important. And I'll in the later slides I'll show how to create the control chart in the pharmaceutical industry. It is a totally practical approach. It's not a bookish theory. Okay, so I think when the all students will go to the industry, they will try this uh, perform this control chart by applying the control chart. This is a very important slide. Next slide. See, this is a typical control chart. This one the average process mean. Already I told the process normal, when the normal distribution curve is designed in the converted into typical control chart. This slide will show. This is the sampling, when sampling the process of products and in design, that slide will show. This is the process means average. This is the upper specification limit. This is the lower specification limit. This is the construction of the control chart. By applying the different techniques, X bar chart, R bar chart, using actually X bar chart is used to monitor the centering of the process to help the control accuracy, and the R bar chart monitors the dispersion of the process. Already I told before the assignable cost and chance cost. So assignable cost already makes the process stable or unstable, and chance cost or makes the process capable. So both expert chart and by applying the expert chart and R chart, we can monitor easily. This is a statistical mathematical expression. How to monitor, how to mathematically express upper control, lower control, X bar. Next. And this is just I'm giving the one example, particularly tablets. This is the R charts. This is the expert chart for the another product tablets. Abnormal patterns in the control chart. So actually in the control chart, typical control charts, your control limits should be within the specification. I will show the next slide. See, one point outside the control limits. Okay. See this one. Next, this is the abnormal control chart. See, it tends to lower specification. So process is not robust. Your quality is not robust. See, this is the most ideal control charts. All data, all your quality within the upper specification limit and lower specification limit. This is a typical ideal control chart.